Hey guys, welcome back to my YouTube channel. Today in this video I am talking about Labfab's CO2 sensor. The CO2 sensor is a collaborative project initiated by the Labfab Rennes France in partnership with the MCE Rennes France. The objective is to propose a sensor easy to mount which allows CO2 measurement in a room. The result of the CO2 concentration threshold calculation is displayed in ppm parts per million and is color coded to determine if there is sufficient aeration. This sensor helps you to determine the periods of ventilation in closed spaces, in particular in the school context. Further, below these are all the supplies, materials and tools which are used for this project. See all the points carefully for better understanding. Now step 1, how to read the data. The link between the CO2 concentration and the air quality in a room makes it possible to establish reference threshold. In our case, we use the CO2 recommendation of the French authorities at 800 ppm and below, recommended for interior spaces in society. From 800 ppm, space must be ventilated. Above 1000 ppm, it is necessary to ventilate the space and it is not advisable to stay in the room. Step 2, how the sensor works. When you plug in the sensor, it will take some time to turn it on. This is a warm-up time necessary for the sensor to display a correct value. Once turned on, you should see a color appear. See previous step. Clicking on the sensor will allow you to view the exact number of ppm measured by the CO2 sensor. Step 3, calibration and common problem. When your sensor starts up, if a noise animation appears, your sensor is not being detected correctly. This can be caused by several issues. The RX and TX wires or 21 and 25 were reversed during the connections. The sensor is not working correctly. To check this, test by looking to see if an orange LED lights up intermittently in the CO2 sensor. If so, it may be miscalibrated. It is important that the sensor is well calibrated to ensure reliable values. The calibration procedure consists of placing the sensor in the outside air. This has a CO2 concentration of approximately 400 ppm and serves as a reference for the sensor. Step 4, solder the CO2 sensor the right way. For this tutorial, solder all the pins of the SenseAir S8 on the inner side so that the pins go up along its case parts as in the diagram opposite. Step 5, cut the wooden case. Download the cutting plans, then with a laser cutter take out all the parts needed to mount with CO2 sensor. Step 6, begin the sensor structure. Fit the two internal parts B on the internal part A, then fit all the internal parts to the part below. Note, the top of the internal assembly should be on the USB side. The lower part must be on the CO2 side. Step 7, wire the CO2 sensor. Place the CO2 sensor in the inner assembly so that the pins protrude inward from the assembly. Then connect the DuPont cables to the sensor. To connect the CO2 sensor and the atom matrix to the DuPont cables in the central wide, hold the one with annotations. Step 8, enclose the case. Place the atom matrix in its slot and place the top piece on the atom matrix. Clip the 8 spacers around the sensor. Step 9, connect the USB to your computer. Check the connections. 1. Last time when connect your sensor via USB port, the atom matrix should turn on. Step 10, install Arduino software. Download and install Arduino IDE. This is programming software that will allow the sensor code to be uploaded onto the M5 Atom Matrix card. Once installed on your computer, start the Arduino software. Step 11. Add additional cards. By default, the Arduino IDE cannot recognize the M5 atom matrix board. For this to be possible, you must add a web address in a field. See photo opposite, accessible via the File Preference menu. The URL to add in the additional cards field is. Step 12. Add recognition of M5 stack cards. Thanks to the previous step, it is now possible to add M5 stack card recognition via the Tools, Card Type, Card Manager menu. The Card Manager opens. You must then type in the search field ESP32, then on the Install button. If the search for ESP32 doesn't give anything, you must close and restart Arduino. It is possible that the previous step of adding URL has not yet been taken into account. Step 13. Add M5 Atom library. For the program to be able to use the specific functionalities of the M5 Atom matrix card, a special library must be added via the menu Sketch. Include a library. Manage libraries. The library manager opens. You must then type in the search field M5 Atom, then on the Install button. Step 14. Download sensor codes. Download one of the CO2 sensor code variant sensor code with variable color animations. Below, see all the sensor codes carefully for better understanding. Step 15. Program upload. Click on the upload button. Uploading takes a little time. At the bottom right, a scroll bar fills in green. When it's done, some text will scroll on a black background at the very bottom of the window. Wait for the next to end scrolling. The LEDs on the M5 Atom matrix board should light up when it's finished. The sensor is the functional. Step 16. Test the sensor. Connect the sensor or you want it and check that it works correctly by displaying a color and a consistent CO2 level. Check that your sensor is properly calibrated. To find out, go outside, wait 5 minutes and plug in the sensor. Its value should be around 400 ppm. If this is not the case, or if you encounter errors, you will probably need to recalibrate the sensor. For this, go to step 3. Thank you.